Hello, good afternoon everyone. Welcome to my course Basic Electronics Engineering. This course is generally made for BTech degree students of second year, third semester. Myself, Gopal Chakraborty, Assistant Professor, Department of Physics, Greater Kolkata College of Engineering and Management, Baraipur, a college under JIS Group Educational Initiatives. You can personally meet me at college premises, ground floor physics lab. You can also send me a mail regarding your query and doubt to my given mail address, that is godphysics6@gmail.com and gopal.chakraborty_GKCEM@jisgroup.org. Students, I have a YouTube channel. The link is given here. You can visit my YouTube channel as I have already uploaded lots of video as per markout syllabus. Please go through that videos, and if you feel any doubt, feel free to contact me. Now, the course pages are www.markoutexam.net and www.markoutwb.ac.in. The syllabus is already uploaded in the university website. Link is given here. If you want, you can download the syllabus through this link. The title of the course is Basic Electronics Engineering. It is under the category of Engineering Science course, and it has a subject code ESECE301. It has a credit 3 and 3 lecture per week. This course is generally made for BTech degree students of second year, third semester. So apart from other departments, only the students of mechanical department have to study this subject as part of their curriculum for second year, third semester. So for this subject, I am your subject teacher. Now, the topic that I am going to be discussed in today's class, that is basics of 555 timer. Its Astable mode, Monostable mode, and Biastable mode of operation. Introduction to Time Constant RC Circuit and its Applications. So these topics are also under Module 3, that is Timing Circuit and Oscillations. Now, prerequisite for this topic is elementary idea of semiconductor physics. The course objective is to provide an overview of basics of IC-555 timer, its Astable mode, Monostable mode and Biastable mode of operations, introduction to time constant RC circuit and its applications. After completion of this topic, students will able to understand the principle of IC-555 timer, these ICs Astable mode, Monostable mode and Biastable mode of operations, and introduction to time constant RC circuit and its applications. Now, 555 timer or 555 timer. IC-555 is one of the most popular and most widely used ICs. IC means integrated circuit. So, it is a versatile and extremely robust integrated circuit. It is used in many applications like timer circuit, wave generator circuit and oscillators. Now, IC-555, popularly known as 555 timer, that was developed by Hans Kamengit of Signetic Corporation in 1971. It was released in two parts, NE-555 and AC-555. The NE-555 parts were of commercial uses with a temperature range of 0 degree to 70 degree C, and the AC-555 parts are designed to meet the military standard with a temperature range of minus 55 degrees C to 125 degrees C. So that means AC-555 parts that can be operated for a very wide range of temperature. It is a monolithic IC and was the first commercially available timer IC. Now, in today's class, the topic that I will going to discuss is the IC-555 timers basics, different mode of operations, that is Astable mode, Monostable mode, Biastable mode, etc. Pin configuration of 555 IC timer, 555 timer internal circuit diagram, 555 timer working, introduction to time constant RC circuit, and choosing time component of RC circuit in timer. So, timing capacitor, timing resistor, trigger pulses, these are the timing component of RC circuit in timer. Now, first of all, as you are going to study IC-555 for the first time, you need to know what is the basic features of it. Now, I will show you one by one. Now, its features. Some of the important features of 555 timer are the 555 timer can be operated at a wide range of power supplies ranging from 5 volt to 18 volt. It is available in 3 different packages: 8-pin metal can package and 8-pin deep and 14-pin deep. Timing can be anywhere from microsecond to hour. It can be operates in both Astable and Monostable modes. High output current. It has an adjustable duty cycle. It is TTL compatible due to its high output current. The output can source or sink a current of 500 milliampere to the load. It has a temperature stability of 0.005% per OC. Now, different mode of operation of IC-555 timer. So, generally, the 555 timer can be operated in 3 modes: Astable, Monostable and Biastable. Astable mode. In this mode, the 555 work as a free running mode. The output of Astable multivibrator will continuously toggle between low and high, thereby generating a train of pulse which is equals to why it's known as pulse generator. Now, it is the best examples for a perfect square wave generator. They are used as an inverter and also used in many of the internal part of the ratio. Selecting a thermistor as a timing resistor allows the use of IC-555 in a temperature sensor. Secondly, monostable mode. A monostable mode, as the name suggests, it stays in its stable states, which are unless an external trigger is applied. In this mode, the IC-555 functions are as one-shot pulse generator. The best applications of monostable is to eliminate is to introduce a time delay in the system. Applications comprise many things, therefore timer missing pulse detection also included bounce-free switch and touch switches as well as frequency divider, capacitance measurement and pulse width modulation and many more. Next one, that is Biastable mode. In a Biastable mode, the IC-555 acts as a flip-flop. As it has two stable states, it can be used to store one bit of data. It is not a great choice for implementing a flip-flop. Now, in this figure, it will be very much easily understood for you the details of pin configuration of IC-555 timer. The 555 timer is available in 8-pin metal CAN package, 8-pin mini dual inline package DIP and 14-pin DIP. The 14-pin DIP is IC-556, which consists of two IC-555 timers. The 8-pin DIP is most commonly used. The pin-out diagram of IC-555 timer in both the 8-pin packages is shown below. So, students, I hope the diagram is clearly visible to you. Okay. Now, the name and numbers of all the pins along with their description are tabulated here. So, point number 1, that is ground. It is ground reference voltage is the output device. Next, trigger, that is 1. So here responsibility for transition of SR flip-flop. Next, point number 3, that is output. So output a negative pulse of all the resets will disable or reset the timer. This is pin number 4. Next, pin number 5, that is control voltage. Controls the width of the output pulse by controlling the threshold and trigger level. Next, threshold, that is compares the voltage applies at the terminal with a reference voltage to third. Discharge, connected to open collector of a transistor which discharges a capacitor between intervals. And VCC supply, it is a supply voltage. Now, pin 1, ground reference voltage. All the voltages are missing with respect to this terminal. Now pin number 2, that is trigger terminal, it is responsible for set and reset transition of flip-flop. The amplitude of the external trigger pulse will influence the output of the timer. The output goes high and the timing interval starts when the input and at a trigger pin falls below half of the control voltage. So here it is clearly visible to you, pin number 2, pin number 3, 4, 5, that is control voltage, 6 threshold voltage, 7 discharge, and 8, that is VCC. Now 555 timer internal circuit diagram are shown here. So this is the basic circuit, 2 comparator and SR flip-flop, 2 transistor, a resistor network. So this is the circuit diagram. Now the comparator, the basics of op-amp. The comparator 1, which provides the R input, compares the threshold voltage with 2/3 of VCC reference voltage. The comparator 2, which provides the AC input to the flip-flop, compares the trigger voltage with 1/3 of VCC reference voltage. The resistive network of 3 resistors will act as a voltage divider circuit. The values of these resistors are 5 kilo ohm, and these 3 5 kilo ohm resistors are responsible for the name IC-555. Now I will explain what is the 555 timer working. The 3 5 kilo ohm resistor for a voltage divider network. This network provides 2 reference voltage of 2 comparators, 2/3 of VCC, to the inverting terminal of the upper comparator and 1/3 VCC to the non-inverting terminal of the lower comparator. When the threshold voltage is greater than 2/3 of VCC, then the flip-flop is reset and output goes low. This will turn the discharge transistor on and provides a discharge path to an extremely connected capacitor. A trigger input is connected to the inverting terminal of the lower comparator when the trigger input is less than the reference voltage 1/3 of VCC. The lower comparator output is high. Now the next one, introduction to time constant RC. So meeting timing requirements is high priority task in most of the operations. For example, the heating process of metal or a material in an industry is timing limited. Hence the meeting in the specific time requirement can be achieved by timer circuit. A basic timer circuit is shown here. The charging circuit consists of a resistor and the collector. When a series combination of an RC circuit is applied with DC voltage, the time taken for the capacitor to charge the peak value is controlled by the resistor. Now the charging time is proportional to the value of the resistance. The rate at which the capacitor charges in an RC circuit is given by the time constant. So RC time constant, generally called the thou, is the time constant of RC circuit, and which is the time taken by the capacitor to charge through the resistor by approximately 63.2% of the difference between initial and the final value. It is also equals to the time taken by the capacitor to discharge to 36.8%. The time constant of RC circuit is equals to the product of R and C. So tau is equals to R and C. So the pulse width and the frequency of the output of 555 timer and determined by the RC time constant. Next, the choosing time constant of RC circuit in timer. A 555 timer can provide delay from microsecond to hour depending on the value of R and C in the charging circuit. Hence, it is very important to choose appropriate value of the resistor and capacitor. When 555 timer is operating in Astable mode, then it requires an RC circuit consisting of two resistor and capacitor, and in case of monostable mode of operation, the RC circuit comprises of a resistor and capacitor. Now, the applications of it. Since the introduction of the IC-555 in early 70s, it has been employed in numerous circuit and application by the researcher as well as the hobbyist. Some of the important areas of applications of 555 timer are pulse generation, time delay generation, precision timing, sequential timing, pulse width modulation. The typical application of 555 timer can be differentiated by the mode of operation depending on the mode in which it operated, therefore either in Astable or in Monostable. So, some of the application of IC-555s are frequency divider, line ramp generator, missing pulse detector, pulse position modulation, square wave generation, pulse width modulation, oscillator, tone bus generator, etc. So, lots of applications are there. So, these are the reference book that you may refer. The evaluation process is same. You have to appear for 70 marks end semester exam, 30 marks internal exam, out of which 15 for exam, 10 for assignment and 5 for attendance. Hope all of you have enjoyed and understand to discuss. In next class I will discuss about transistor amplifier. So, thank you.